And welcome everybody to the Daily Space Weather. We've got at least 2 new sunspot groups to get named in the Northeast. The real place to watch is the Southeast, because we've got some extremely magnetically complex sunspots down there. Let's take a look. That's the past 24 hours from SDO 171 angstroms. And thanks for tuning into the Smash News Network, least busted name in news. Don't mind us, we're just bringing you the most detailed imagery of the sun and most comprehensive space weather content you'll find in the known universe. So this is the most likely place to see major flares. We do have an awesome coronal mass ejection that is currently unfolding. So lots of exciting stuff happening, a well-defined coronal hole, and lots more. Again, likelihood of major flares now much higher. And we've seen a little uptick in the solar radio flux. We can expect to see that jump up majorly along with the sunspot number. We'll see an increase in sunspots of like 100 today. And also a major uptick in the radio flux is coming in the next day or two. Here we've added 193 angstroms to the 171 angstroms to allow some additional extended corona to show up there. That's a different species of ionized iron. You can see this CME happening down here as we just caught it there at the end of the 24-hour video. These are all 24-hour videos. Again, new sunspots there, at least 2 new groups in the Northeast. We've also got a huge plasma filament right up here. That's called the Gene Simmons filament. We've been naming plasma filaments after living people on Twitter. Make sure you follow us over there at Twitter, at Smashomash, all over the internet. You'll find us on various social media sites. See smashomash.com for details of those. Don't forget to follow the hashtag NameThatFilament, Space Weather, and SpaceWX over on the utterly broken, shadow ban included, quote, social media, and quote platform, and quote. There's your southwestern limb. We've got some sunspot groups setting down there. Again, all of the excitement is on the eastern limb at the moment, including this very well-defined coronal hole system and the sunspots that trail it. So let's take a look at sunspots here. This is the imagery from yesterday plus today. And check out the size of that sunspot, much larger than the Earth. And another very huge group following it, as well as some very complex magnetic fields behind it, which should become more obvious when you see the SDO colorized magnetogram. That's also yesterday plus today. So we'll have, I believe there's going to be another name group here. So we're going to have 3 new named sunspot groups today, most likely this group here, this one up here, and this one over here. So we'll get into sunspots here in a minute. Let's take a brief look at what's going on planet Earth. Volcanoes that are erupting include Sakurajima, which is producing a 7,000-foot plume of volcanic ash. Suwanosejima, 7,000-foot plume of volcanic ash there. Also flight level 070 over both volcanoes. Semeru exploding, producing a flight level 140. It's a 14,000-foot ash plume over East Java. Dacono exploding, flight level 070 also. Popocatépetl exploding in central Mexico, flight level 220. Volcanic ash not observed over Fuego or Revenador, but continuous emissions have been observed from Sabancaya in Peru, so please don't pole vault the caldera. Let's check out global seismicity. And indeed, there was one major quake which caused major damage, most likely. It's a 6.8 there at Bolivia. And unfortunately, that one occurred just offshore at a highly populated area there, most likely because of that harbor. So that's like a river delta area, as you can see, and lots of towns around that location. So probably quite a lot of damage there from that 6.8 that came in at 1712 yesterday afternoon, Universal Time. Let's see what else is happening here on the list. Argentina also had a 5.0. That was at 1541. And then about an hour and a half later, that 6.8 strikes Ecuador. We'll cite other quakes over a 5 magnitude. it looks like besides that, things are mostly calm there. Only 2 quakes over a 5 magnitude. Is it the calm before the quake storm? Let us know what you think in the comments. And thanks to everybody who's left comments. Let's continue on and get back to space. Before we do that, let's pause for station identification. Thanks for leaving comments, Mr. Bordages. So here we are, back to space. That's the house favorite and many of our viewers' favorite wavelength. The 171 angstroms wavelength has always inspired me to study the sun more. And what's super exciting about heliophysics is that it gives us insights into cosmology. Yeah, there is a relationship between heliophysics and cosmology because, well, if the sun is much weirder than most people believe, it's super important to understand this because of the implications on cosmology. So that's how I ended up going backwards from cosmology into heliophysics, because back in the mid-90s I realized that there are some holes in that branch of astronomy, heliophysics. Anyway, the 10.7 centimeter radial flux now up to 140 solar flux units. And of course the sun is jumping up and down, doing all kinds of things, casting light on our daily activities and saying, hey, look at me, figure me out if you want to become an interstellar species. Kind of important to understand how stars work. So that's what we're working on. It's one of those situations in science when you end up with answers to questions not asked, and more questions as opposed to answers to questions asked. So anyway, there's the 1-year graph of the radial flux. It's the black line. You can expect this to uptick big time in the coming couple of days here, and expect the sunspot number to rocket up. It's going to go up to like 130 today. We're going to see like 100 sunspots added. Mark my words. And the space weather enthusiast dashboard here, not forecasting any space weather storms, geomagnetic unrest, etc. We do expect to see a possible glancing blow from a CME that we covered yesterday. So that should arrive, let's see, that should be midday on the 21st. So midday on Tuesday the 21st, we can expect a little uptick. Maybe that actually is some geomagnetic unrest forecasted by NOAA there. Perhaps that's what it is. Let's just see what their Enlil spiral looks like. Do they have it modeled yet? It was not a directly Earth-directed CME. It was off to the... Well, they do have something modeled there. It looks like it's off to the southeast. I would have said it was off to the southwest, but anyway, expecting a minor CME impact. So here's Earth's magnetic moment from space for the past 4 hours for today, Sunday, March 19th, 2023. The Geospace Magnetosphere movie is depicting magnetohydrodynamic pressure. The units are nanopascals. It's derived from the Space Weather Modeling Framework, and if you want to read about that, click the Details tab. There's a link to the Space Weather Modeling Framework. You can read about all the data points that are used for this. And there are a lot of data points. Here's Earth's magnetic moment from the ground. We show it daily on the channel. The past 4 hours of geospace delta B. That's changes to Earth's B field in nanotesla. Those units are magnetic flux density. Continuing on to the KP index, a global geomagnetism index. KP2 is the current situation. Planetary K index at 2, geomagnetically calm conditions. And let's look at the real-time solar wind, which was measured out here at Lagrange 1 by the ACE and Discover. Current conditions are about 430 kilometers per second for the solar wind speed, solar wind density just under 5 protons per cubic centimeter. The rest of that's fairly unremarkable. And let's move on to our GOES magnetometers. There you go, GOES magnetometers over the past 3 days. Fairly smooth there, got a pretty big range. And by the way, we've just crossed a sector boundary crossing. The Earth is now in a South Pole-oriented current sheet. We'll get to that next. And there you have it. There's the North Pole current sheet depicted in green, South Pole current sheet depicted in red. And again, Earth has just snapped into the South Pole-oriented current sheet. If you look at the final image, there's the last image. And keep in mind, this data is actually nearly 2 hours old when we created the video, 1 hour and 38 minutes old. So Earth is likely to have already snapped across, and that could be these variations in the magnetic field there. Probably not. Do we see any indications up here in the real-time solar wind? The sector boundary crossing could be happening as we make the stream. It's ultimately not that important anyway, folks, although it does have some minor effect on the plasma, as we are talking about the polarization of the plasma here. So the heliospheric current sheet is the solar wind. It is polarized by the solar polar fields. So that's what's going on with that. And let's take a look at the line of sight field plot here next. There's a line of sight field plot. The sun's B field depicted here in blue, north and south fields in green and red respectively. Let's move on to coronal holes, as we've got some very well-defined ones, especially in the southeast. So ahead of these massive sunspots, we have a very well-defined coronal hole. Keep in mind, folks, that coronal holes are also solar radio jets. There are high-speed solar wind protons blasting out of there. And the solar wind, if you're wondering, it consists of not just hydrogen nuclei, but also helium. It's about 90% hydrogen, and the rest is mostly helium and electrons, and then with a little sprinkling of other heavier elements, which in astronomy we call those things metals. Anything more massive on the periodic chart than helium is considered a metal in astronomy. And let's bring up the latest image. There you go. You can see that sector boundary crossing right here, this ridge in the solar B field. And let's take a look at coronal holes. And a quick reminder that coronal holes are a feature of the solar atmosphere. When you look lower down, like 1700 angstroms, you're looking at the upper chromosphere there, essentially, the very, very low corona. And that 1700 angstroms wavelength, you don't see anything going on down here because, again, coronal holes are a part of the sun's atmosphere. So they're giving us indications of the polarity of the solar atmosphere, known as the corona. So the chromosphere is where all the exciting stuff is going on, but the corona gives us all kinds of insight into solar activity. So here you've got this very well-defined coronal hole down here in the southeast, and another one over here. That's a North Pole. So this one is a North Pole-oriented coronal hole, and this one is south, and the sector boundary crossing is something like this. So that's what's going on in terms of coronal holes. We'll get to the sunspots here in a minute. First, a close-up. That is a very well-defined coronal hole. And let us know in the comments what you think. I'm thinking about starting to name coronal holes after land masses. Like that one, you might be able to call that the Antarctican coronal hole, right? Because it's kind of shaped like Antarctica. Anybody see that? All right, anyway. Let us know what you think about naming coronal holes after land masses. I like that idea. I like it as much as naming filaments after living people. And let's continue on to sunspots here. So the sunspot situation, again, we're going to see a massive uptick. So this sunspot right here is going to get a name, most likely. That'll be 3258. Up here we'll have 3259 and 3260, most likely. So we'll see at least 3 new named sunspot groups. And here's your SDO magnetogram for the past 24 hours. Again, the place to really watch is the southeastern limb, as there are massive sunspots and a lot of magnetic complexity down there. You can see it in the magnetogram. Let's switch to SDO intensitygram. So that largest sunspot down there in the southeast also grew a little bit since yesterday. And that one in the northeast, one rose and one formed up in the northeast. So that's exciting stuff. We're going to get to energetic particles and solar flares here next. First, some close-ups. So those are some exciting sunspot groups down there. Lots of magnetic complexity, lots of plasma suspended by their magnetic fields. Here's what's going on in the northeast. We may have some more groups forming up here as well. We do see possibly, we may have as many as 5 new named sunspot groups today. So expect an increase in the sunspot number of like 100 sunspots. And by the way, if you enjoy the content, help out the channel by checking out the links below the video. You can find links in the description. If you're viewing on BitChute, make sure you view the videos on YouTube. You're missing like 90% of the content. And if you visit the Redbubble link below the video, you'll find the merch shop in order of best selling. Now, we have it sorted here in order of newest, but our link below the video shows them in the order of best selling. Today's featured product is Project Management Facts, because it can either be bad, in which case it'll be cheap and fast. It can be expensive, in which case it'll be fast and good. Or it can be slow, in which case it is cheap and good but not fast. You don't get all three. You can't have all three. And if your boss thinks that you're able to accomplish a task that's cheap, fast, and good, you probably need a new boss. Only the hackiest project managers in the world think that any project can be cheap, fast, and good. So understand this, because only the most noobified project managers expect a task to be cheap, fast, and good. That's complete fiction. It doesn't exist in reality. So pick two and share some project management facts with people you meet in your daily life. Anyway, the Ghost Proton Flux just saw a moderate spike here, a little tiny spike, really, just a little spike there. So a little bit of an uptick there, some additional relativistic particles showing up there around the earthly system. Keep in mind the GOES 16 is a geosynchronous near equatorial orbit. It is inside the magnetosphere. Here's our GOES X-ray flux, and that proton event might have been caused by this little spike here, that little C-class flare. And flaring has been minimal here, although you can expect to see a large uptick. Don't be surprised to see an X-class flare at any moment. And here's another 24-hour video. This is 93 plus 131 angstroms from SDO. And there's the northern hemisphere for your viewing pleasure. And there's the south. And once again, the most exciting place to watch is going to be the eastern quadrant there, because especially the southeast, those are some serious sunspot groups. They're also in close proximity to each other, which means they can exchange plasma. Their magnetic fields can overlap, cancel, and even amplify each other. Continuing on, we encourage our viewers to look up overhead, so we're always interested in what's going on up there. At the moment, we've got the Moon, Saturn, Jupiter, and Venus, and also Mercury very close to the Sun there. And you probably won't even be able to see that in the evening sky, because Mercury is quite dim to begin with, and it being that close to the Sun and so on. But in a few days, you should be able to see Mercury in the evening sky just after sunset. Here's our solar system forecast. This is where things are located. Now, keep in mind, this is not to scale. These objects are very far away from each other. And consumer tip: magnetic fields do not control planetary orbits or the motion of things like galaxies. They just don't. Because if they did, we would see this happening constantly, and magnetic fields would then affect things like planetary orbits. They don't. So if you're watching channels out there that keep telling you nonsense about, oh, the gas giants are going to pile up and Earth is going to go past the gas giants and something spooky is going to happen, that is not astronomy. That is utter bollocks, nonsense, garbage, crap, ridiculous silliness. Don't believe it. Magnetic fields don't control planetary orbits. They're controlled by things like inertia and gravity, folks. So, here's our solar system forecast. This is where things are today. Here's where things will be in a week. We will have a crescent waxing moon on the 26th. And let's take a look at some coronagraphs now that we've oriented ourselves on this lonely side of the solar system. So here are yesterday's coronagraphs. We do have some CMEs happening there. There's one pretty good one out of the southeast, and also one right at the beginning of the video there out of the southwest. Also some coming out of the north there. So several CMEs here to evaluate. 160 frames showing up today too. So that's yesterday's imagery. We'll let that play through one more time. So far, I don't see any Earth-directed CMEs there, likely. Here are today's images. That's 28 more frames. And let's take a look at the view from stereo A and the Soho Lasco C3, which may have some missing data, but we're going to check anyway. So stereo A is located right there, only a few degrees behind the Earth, orbitally speaking. And there is stereo A plus the Soho Lasco C3. Also Mercury making an appearance there. And let's allow these to play through just to give us some checks and balances here. So there's a CME that may have that earthly directed component. Like I said, it's off to the southwest for the most part. We do expect a minor CME impact like midday on the 21st, which would be Tuesday. The rest of those CMEs I don't think are earthly directed. And the one that's occurring right now, it's coming out of the southwestern limb. We'll show you that here in a minute. First, let's take a look at some 24-hour videos. This time we put in 193 angstroms for the SDO portion because we do see some very large coronal tufts happening there. Some helmet streamers, you could call them, like this one down here. That's part of the reason why we use 193 angstroms, because it does show you the extended corona. And what you're seeing, the reason that looks a little choppy there is because there's some missing data from the blue portion. That's the Soho Lasco C3, but the C2 is largely intact there. So I don't think those are Earth-directed CMEs. The one that's happening out of the south right now, you'll see right at the end, you'll see a little bit of a peekaboo right there. And we're going to show you that here in a moment, as that is still unfolding. It's probably not even fully left the corona yet. So first we're going to look at filaments. Again, we do have one named filament up here, and this is really just one filament, this whole long thing. That's all the Gene Simmons. This one down here, I mean, maybe you want to name that Paul Stanley or something, I don't know. But in any case, there is another filament to its southeast, and you can see it's a prominence over here. It's just rising over the limb there. Part of that is likely suspended by that new sunspot. So if you do want to name filaments, you can always join us over on Twitter. Make sure you follow the hashtag #NameThatFilament, hashtag #SpaceWeather, etc. And another reason to join us over on Twitter is that we have the free giveaway for Hemp Lucid Mushroom Gummies pinned to the Twitter profile. So just click on that if you're interested in trying the Hemp Lucid Mushroom Gummies. We've got gummies for stress, sleep, focus, and more. So check out that link if you haven't done so. More on the Hemp Lucid product a little bit later in the video. The free giveaway continues. You do have to pay shipping. Next, the 304 angstroms wavelength for the past 24 hours, and you will see the CME propagating down here. Let's zoom in on that. There's just the southwestern limb. And right at the end of the video, you'll see a major. There you go. We'll let it play through one more time. Keep in mind that is a 24-hour video. Let's switch to the 2.5-hour video from the Go 16 SUVi to show that berserk CME happening. That is a good one. And it is still on its way out there, but it looks like it's almost subsided here. So not particularly expecting that one to be an earthly directed CME, but you never know. Sometimes the magnetic fields drastically affect the trajectory of those things. I mean, occasionally we see Earth-directed CMEs that emanate from the invisible portion of the sun there. That's behind the eastern or western or even northern or southern limbs. Let's zoom out for the full disk view there. Spectacular coronal mass ejection there happening as we stream the video. By the way, fun fact, our videos are streamed live to Twitch. Our videos are streamed live to Twitch typically and then unpublished. So if you don't catch it live, you got to wait for it to become exclusive on YouTube, and then after the YouTube premiere, then it appears on BitChute. And again, if you're viewing the videos only on BitChute, you're missing like 90% of the content. So go subscribe over on YouTube and watch the rest of our videos, you're missing, again, like 90% of our content. Anyway, here's our bonus features segment, starting with charging hazards. We've got some minor charging hazards here in the Central Pacific caused by low-energy electrons on the surfaces of satellites. No big deal there. Here's our GOES electron flux. That's measured at the F layer of the ionosphere using radiography by the GOES 16 and GOES 18 geosynchronous near-equatorial satellites. We're just in a fairly normal range here. And let's check and see what the forecast model's like, as we did do a forecast yesterday. So, nope. I was off. I expected it to be a little bit higher than it is. I forecasted it like here, and it's only like here. So anyway, see yesterday's video as we do the daily space weather. Daily, hence the term daily space weather. Anyway, the green boxes are the forecast. The yellow diamonds are the observation. I would expect this to continue to climb. So expecting it up there, and in 2 days, expecting it back down here when the CME impact strikes. It will be minor. We'll be lucky to see a KP4 or 5 from it if there's any signal to measure at all. Next, the 1-year chart. That's your electron flux from Solon.info in the 1-year graph, kind of at the low part of the range here. That's part of the reason why we're expecting an uptick. Also, we just recently saw a coronal hole high-speed wind subside, which typically leads to upticks in the electron flux. Next, the F layer of the ionosphere. And it's interesting to immerse yourself in the data. Here's the vibrational frequency of the bridge between Earth and space. And if you're not familiar with the penetration of electromagnetic radiation, thermospheric temperatures, and molecular concentrations, feel free to pause the video on this frame. Here is the vibrational frequency of the F layer. We are certainly seeing some high-frequency anomalies continuing, but we're also seeing some low-frequency anomalies mixed in here. So let's let that play through the full day. And here is the anomalygram. That's anomaly in megahertz from a 30-day median. We've also added features for the electron content here, which we're going to get to. We'll let that play through all the way. Some low-frequency anomalies happening there around the equatorial Indian Ocean, around the North Polar region, parts of Europe and Asia. High-frequency anomalies mostly in the southern hemisphere, and some rapid shifts from high to low-frequency anomaly, especially around the South Atlantic anomaly, which is kind of right over the South American continent, right about here. Anyway, there's the latest image. That's 1315 universal time ionogram and 1315 universal time anomalygram. Coming at you a little bit late today because, well, it is the Sunday edition after all. Anyway, the total electron content, we're going to show that next from a global scale, North America and the U.S. It's the free electrons out to about 12,500 miles of altitude. And there you go. Those are the most likely places to see GPS errors, and we have quite an orderly total electron content at the moment. Those electrons are fairly where you'd expect them to be, which is centered around the equator at noontime. So those will be the most likely places to see GPS errors. We do see some significant anomalies, so we're going to show you the anomalygram for North America and for the U.S. These are some added tabs, and it's pretty rare for us to add any tabs to these videos, as it took us years to figure out which ones to cover. So we are seeing some high electron anomalies there. So you can see some right there. Bring that back. So there are some significant high electron content anomalies. Those might not show up on the other imagery. And that's part of the reason why we started showing it, because if this has any predictive value for things, we want to show the data on the channel, as this channel should be a resource for other channels that claim to forecast things. So here's just the U.S. Again, you'll see that large electron anomaly right there. And it was pretty rapid and pretty much out of nowhere. So that could be some sort of a signal. I won't get into attempting to forecast anything with it. However, again, this channel should be a resource for other folks covering things like space weather and geophysics. And thanks to everybody who's tuned in. Congratulations again on realizing that the channel exists. Next, our latest solar intensitygram and latest magnetogram, because, well, we've got this new group, so let's take a look at that real quick. There you go. Right now, it looks like an alpha class sunspot. This group up here, right here, that is already a beta gamma class sunspot group. We do see South Pole trailing umbre there, right there. So, and also we do have some other new sunspots that are possibly going to get names up here, or have they already evaporated? Anyway, we're likely to see at least two new groups up there, and we're likely to see at least one new named group down here, this group right here. So that's also a very magnetically complex sunspot group. Let's show that on the magnetogram. Can we fit them all on there? Oh, that's not bad. A little bit lower. There we go. So there's your umbre SDO intensitygram, and there is your magnetogram. That's beta gamma delta class. That's beta gamma delta class. This one here looks like it's only alpha class. And this one down here also beta gamma class. So significant sunspot groups there. Again, the most likely places to see major flares is certainly this region down here. Don't be surprised to see an X-class flare at any moment. There is plenty of magnetic field complexity to support this possibility. And let's continue on to meteorology. And before we do that, a quick reminder that we'll be streaming on Monday at about 5 p.m. Eastern Time. As we have entered your final days. Yes, your final days. It's your final day today of winter, or if you're in the southern hemisphere, of summer. And we want to be the first channel in the world to wish you a happy spring. It'll happen at 5:24 p.m. in 20 seconds. So join us for our equinox stream on Monday afternoon. We'll talk about all kinds of things, maybe not even space weather. The official homepage of the Smash team is smashomash.com. And welcome to the Neo Renaissance. Again, congratulations on realizing that our channel exists. We're frankly surprised that you found the videos. Press like, subscribe, share, etc. Visit our links. And consider becoming a member of the Smash team if you enjoy the content and you'd like to see it continue to exist, remain publicly visible, and free for all to view. One of the links you can find on the homepage is the link to the Hemp Lucid shop. So check that out. Make sure you enter the promo code SMASHOMASH to save some dough, some cash on your checkout. Don't be a gaping gash. Save some cash on your checkout at Hemp Lucid. Use our link for your shopping or just enter the promo code SMASHOMASH. Shop by solution, CBDs, mushroom gummies, and lots more on the Hemp Lucid site. Smashomash.com/SmashTeam is how to support the channel. We are still on Patreon. There are PayPal one-time donations and lots more. Help us write the paper, the most important in hundreds of years, explaining a plausible mechanism underlying the solar sunspot cycles. CARP. CARP. Yeah, that's what I have to say, is CARP. And our Gold Smash Team members might know what that means. We just put up a post yesterday for Gold Smash Team members only. Just click posts after you've logged in to see your latest posts. We also send out email notifications for things like disaster alerts and our latest videos, as many people have complained about not receiving notifications from certain video hosting platforms. A video hosting platform. Next, we're looking at sea surface temperatures and currents. So we're starting out meteorology with this. And why? Because the equatorial Pacific Ocean is turning back to normal. We had lots of anomalously cold water all around the equatorial Pacific there for years, and now it's breaking up. That's one of the signals that it is an end to La Nina. So now, of course, the likelihood of El Nino is coming back and so on. I won't get into the specifics of any of that, but that's sea surface temperature anomaly and ocean currents. So the animated portion is the currents, and the colored portion is the sea surface temperature anomaly. You can see the equatorial Pacific here reaching much more normal temperatures there, as opposed to being exceedingly cold. So keep in mind also that the Pacific Ocean is the world's largest surface heat sink. And if you think mankind is able to heat up or cool down this giant body of water, think again. It requires more calories than mankind is able to produce to heat up the Pacific. It's just not happening. Mankind is also not going to be heating up the Indian Ocean, the Southern Ocean, or cooling down the Arctic Ocean, or cooling down the Atlantic, or any oceans, period. That is beyond mankind's control. And the idea that mankind can control the weather, the climate, etc., or things like, weather and climate, is just the pinnacle of arrogance and ignorance. Mankind does not have this capability. It's cute that a lot of people think mankind does. Mankind just simply doesn't, in my opinion. And if you've got a differing opinion, feel free to let us know in the comments. Keep in mind, we do not censor our comments. So if you make a fool of yourself, you may be berated by our other viewers. And nobody will get censored. We encourage all legal speech on the channel. We're real free speech purists, not fascists who say my fascism is better than yours. That's just ridiculous. Anyway, here's our regularly scheduled meteorology segment, now that we've showed you sea surface temperature anomalies. And that is the jet stream scenario for the eastern world as fall approaches the southern hemisphere. Here are the surface winds of this side of the planet. And there's a powerful anticyclone there in the northern Pacific. You see that clockwise rotation? That is the sign of a high pressure zone. In other words, there's a lot of nitrogen there and likely clear skies. Here are the surface winds of the west. We've got an odd wind ridge here in the Atlantic. It's a spot of a likely huge pressure gradient. So if you check out the mean sea level pressure, you can see that there indeed is a pressure gradient there. No surprises to those of us who understand atmospheric physics. If you understand atmospheric physics, congratulations, you can forecast your own weather. Here are the jet streams of the west. And the jet stream to the central world, that's Africa, Europe, and the Middle East. And these are the surface winds of all y'all folks in the center of the planet. Next, we're looking at the sunrise here over the Atlantic Ocean. So that is your also sun rising over the Pacific Ocean for South America. That is the visible satellite. We don't often use it on the channel. We usually use the 3.9 nanometer infrared radiation. But it's so late today that we're getting some pretty good imagery there on the visible. So let's do that instead. And we're only 1 day away from those lines being vertical. Of course, the spring equinox is when both equinoxes are when Earth's equator passes over the sun's equator. Pretty basic. That's why the lines get vertical. So we're almost as close to vertical as we can get on those. And here's our weather.gov map. If your location's lit, click your location. Lots of hard freeze warnings there in the southeastern U.S., including some even right on the Gulf Coast. So we've shown you the key. That's about all we can do there. Those are too many counties to cover. Weather.gov is the location. Here are some forecasts. This is your temperature anomaly forecast for the GFS model for the next 72 hours. Keep in mind it is depicting degrees Celsius. Here is our pressure and precipitation forecast for the next 72 hours. Same model, the GFS. And check it out, some additional precipitation coming to California. Well, thank goodness they haven't gotten enough precipitation there. Let's see what the snow totals will be like, as there are some additional major snows coming. Check it out. Showing over 3 feet there for portions of California. Again, GFS 72-hour positive snow depth change forecast in inches. Let's take a look at the Euro model. So there's the GFS model for the next 3 days of new snow. There's the Euro model for the next 3 days of new snow. Again, GFS and Euro, they're pretty well aligned there. So you can expect those forecasts to be quite accurate. Next, our lightning mapper. We did see some significant lightning here around Florida. Looks like no terrestrial strikes. Here's our current lightning map from lightningmaps.org. Check it out next time you hear thunder. It'll even show you the likely propagation of thunderclaps. So, hey, Florida Keys, there's some thunder rolling in. We've got some active lightning strikes there in Indeed, in Germany. Also in the North Atlantic Ocean. All right, so let's close this mother out. Here is vertical motion in the air column. Ground-based U.S. Doppler radar systems. Hey, how about a little precipitation there for California? It has been, shall we say, a moist winter in the land of fruits and nuts, the left coast. Here is clouds and fog over the lower 48. It's still dark on the western part of the country, but the 3.9 nanometer infrared radiation map does show you clouds and fog even when it's dark. Use it to see the aurora, perhaps. And last but not least, what in the hell? Okay. Last but not least, we're closing out the video early because my browser just crashed. So thanks for tuning into the Daily Space Weather. It's our Sunday edition. A little bit of an oddity there. I've never seen the browser just mysteriously close on its own, but it did. So we'll see you soon. Thanks for tuning in. Congratulations on realizing the channel exists, and may that solar wind be at your back. Also, don't forget to visit the links here and here and here.